Good afternoon. Happy Friday.
Hello, friends of Friday. How is it
Yeah.
going?
Hey, good afternoon.
Yes,
It's
okay.
not a moment too soon as far as I'm concerned. I'm ready for Friday.
Hey, Drew, your microphone is a bit quiet.
Thank you. How about that?
Try
Is that
again.
better?
Yeah, a little better.
Oh, wait. How about this? Is that better?
Much better. Yeah.
I'm sorry. When I switch between conferencing tools, my laptop just insists on changing my microphone. I don't know why. Okay. So Anil is out, but we talked to Anil, and I think we can work on the kind of that table we were working on, um, and the error classifications. I think we can make progress while Anil is out, and Anil agreed. So I'm not blindsiding him, and I think that we had largely come to an agreement last week, and we just need to work through the details. So if it's okay with folks, that's my proposal. We just keep going through the docs. So, did you have anything else you wanted to cover, Yogesh?
No, not really. Yeah, so we'll transition CPAD discussion into RAS API. So that is something I think we also discussed. We'll try to make quick progress on that one.
Yeah.
I think over here we need to really somehow put stake in ground. I think it bothers me a little bit that we are we are refining the definitions of error types for 2 years now. That's something we need to get out of.
I agree. Only consolation to me is that every time I read it, I was confused and had to reconvince myself that it was right. So maybe this will help me not have to do that anymore. I think it was a little confusing, to be fair. But
Yeah, yeah, okay.
let's push
Yeah.
through. Let's see if we can just get it done and put it
Yeah.
behind us, and maybe not do it again. Does that sound good?
And I think I don't know, Shubda may not be able to make it today also. I think she had a conflict or she may join for part of it. I know Vilas is traveling, but we have Tanya here, so that's great. And yeah, we have Jyotika, Dean, Charlie. We have good quorum.
Yeah.
So
Okay.
what did you have in mind? The next section, right? Okay.
Yeah, well, I want to talk a little bit. So Mita is really good at, I just appreciate fresh eyes and at this, and she made an interesting observation. She's like, hey, there's this non-favorable recoverable error, but we're saying the kernel panics. What gives? And um, and Anil said recovery is optional, and the problem is that as far as the hardware is concerned, you can recover. But as far as the OS is concerned, it might have been an important OS thing or might not have been, but the hardware doesn't know. So the hardware says this is a recoverable error. The software ultimately decides. And so I thought that was a good enough question that I wrote a small paragraph to clear that up, and just wanted to run that by you. Um, and so the severities are defined in terms of the hardware's perspective. And the software may decide to treat it differently if it needs to. And sometimes the hardware might even promote the error. It may just go, you know what? When I see this corrected error, I know my performance is just tanked. So I'm going to go ahead and shut down. And that's a software prerogative. So that's what I'm trying to say is, we're really just saying these severities are defined in terms of the hardware's view of it, and software does what it has to. So if you all could take a look and tell me if I screwed up, I'd really appreciate it.
I'm not 100% sold on the fundamental idea that we need to have a software and a hardware view when it comes to handling of the errors. I think that should be a holistic platform.
Oh, I agree with
perspective.
Drew. the hardware tells you what's capable of happening, it can continue if you can fix the software state, and there are cases when you cannot. So the ultimate decision will be holistic, but the pieces will be exactly as Drew described them. I think this is a good job.
So hardware is communicating that here is an error. It was corrected. I corrected it. Done. Or
No,
here's
no,
an error.
no. It's not what it says. Not what it says. It says it's recoverable, which means, in general, it's uncorrected, but the system could continue operating if you meet some.
So yeah,
criteria.
that's another class. Yeah, that's another class of errors. But it was corrected by the hardware. Then there's no problem, right?
But my point is that software can decide whatever it wants to for whatever reason it wants. But in this case,
Yeah,
you know,
I see your perspective. You're just saying severity is the hardware's view of severity, whether it was able to correct it or whether it thinks an action is required or whether it was not able to correct it. And then as a platform, software can take a view. Okay.
yeah, because like if you know if you have poison, you've lost some data, and if you lost data in a critical OS structure, then the OS it's legitimate. That's a reasonable thing for the OS to do is go,
Yeah.
I lost something I really needed. I've got to go down. But if it was just in some user application, you could shoot the process that was affected, and the rest of the OS is perfectly fine.
Think of
So
it in terms of layers, just like networking layers. The hardware is the lowest layer, and then the OS is a layer above that, and the application's a layer above that, and they're all connected, but they're individual.
So,
yeah.
so I've got a question in terms of, I understand this, how we're kind of getting twisted up in this discussion, but I'm not sure about what hardware can do. It's like for ECC, ECC is going to run whether the error was corrected or not. Hardware's not going to do anything different. It's just going to do the math and either correct or not correct the error, and that's it.
Oh, no. There's one other critical thing the hardware does, and this is absolutely drop everything vital. It will mark the transaction as poisoned and synchronously interrupt any task that tries to use that poison. That's critical for containment. So there is one thing more.
Okay, so there is, if designed properly, the hardware can do that without any software intervention. Okay. Yeah, understood.
Well, and that's actually the crux of it. That is the fundamental thing, is that the hardware goes, I know something's bad, so the moment anyone actually tries to use it, I'm going to hit them with an interrupt that jumps into the OS, and the OS will look at the situation and assess it'll decide what it can do about the situation. And it may say, I needed that data, it was my data, I don't know what to do anymore, I'm panicking. Or it could say, but the hardware tells the OS that. So there is very much something the hardware has to do here.
And something the software has to do, right? In the poison example, poison is useless without software that can handle that condition.
But what I'm wondering is that when the hardware encounters one of these situations, is it going to do anything different, or is it just going to issue an interrupt, which then implies, either the software can or cannot respond?
Well, if it's a corrected error, it doesn't necessarily need to do anything. It just logs it and keeps running. But
right now, so with an uncorrected error, I think what I heard you say is the hardware could actually be designed to shut down without any software intervention. It just says.
That's not what I'm saying. I mean, you could just automatically promote the poison generation to a fatal error and crash the machine, but that's not the best practice. The best practice is to poison it, and then when someone accesses it, so that poison could get overwritten before it was ever used, in which case it was never consumed. So there are two things to this synchronous interrupt. There was corrupt data that was marked as poison, and there was someone that actually tried to use it.
But again, that's that. Now we're at the software level.
Yes.
So Charlie, if I can give you a principle that applies here and applies always, you put mechanisms in hardware, put policy in software. So the mechanism is for hardware to earlier poisoned it, and then it captures the poison and it interrupts and drives the software. Now it's up to the software to decide what happens next.
And
Yeah.
still trying to get my head wrapped around how a
Well,
CE is different than a UE.
maybe we can talk offline because I hate to do
Sure,
that with
yeah.
a big group. But I also, Charlie, have a poison paper that I've written that describes this.
Have you
And
got it past Microsoft legal? Can you?
almost,
Okay,
almost,
yeah.
I'm
Yeah, I
working on
would
it.
love to see that.
And what I would like to do is maybe we as a working group could generate artifacts like that that are just like I'm not trying to invent anything new in the poison document. I'm just saying here's how poison should work. You should synchronously interrupt anyone that uses it. If it's going out I/O, the I/O device should fail the operation that got poisoned. Stuff like that, so
Right.
that you have error containment because poison is it's an error recovery mechanism, but it's also very importantly an error containment mechanism.
Sure,
And
sure. But kind of what my question is, can that all be handled in the hardware without any software intervention?
no, it can't.
If it can, then then it's important to differentiate, fatal hardware errors versus fatal software errors. But what I'm thinking right now is errors are errors in hardware, and it's the
Yeah.
distinction of whether they're fatal or not is a software concept, not a hardware concept.
No, so sometimes an error is fatal. So let's say that you get
But
back. A lot of times you have transaction tracking, and you have a fabric that has credits to send transactions out. And if you're losing those credits, the fabric can deadlock. When that deadlock occurs, nothing in the hardware can make forward progress anymore. You've hit a fatal error. So at that point, the OS is no longer involved because it's not running. So the hardware triggers the fatal error, and then you have to find a way to gather that data somehow. But the software response is not happening because the software is not running anymore.
Okay, yeah, let's talk offline, Drew, because I understand what you're saying, but I'm still having difficulty getting my head wrapped around how hardware really changes its behavior under different types of errors versus
Okay,
just
I can do
going
that.
through ECC. The ECC circuits behave the same regardless of whether there's no errors, there's correctable errors, or there's uncorrectable. It's the
That's
hardware is
right.
just handling all that the same. It doesn't really care. It's
So
not changing.
that's at the detector level, but then
Yeah.
once you decide what you detected, the behavior does change.
Okay. So yeah, let's discuss it offline. I don't want to kind of rat hole. I think we do need to progress
Yeah,
forward.
yeah. I mean, you can ping me. We can find a time to have
Sure.
a brief discussion on this. I'm happy to do it.
Sure,
Um,
great.
but anyway, so yeah, I guess I would encourage you all to take a look at this. Then, um, I think it reflects, and it answers Mita's question. And this is, like I said, the beauty of fresh eyes, right? That she saw this thing that was confusing, and this stuff isn't well understood. So our document does need to describe things to someone who doesn't necessarily know the subtleties like we do. Okay, so that was one change I made, and then down here I made a series of changes, and what I'd like to do is just given the discussion we had last week, go through and accept the changes if we agree. Um, so we have corrected errors, and bare metal. Firmware first works, OS first doesn't because we may not have an agent. So this stuff hasn't really changed. I just said, I don't know why this says this. Maybe Anil made this change, but I think this is the right answer, and I will make that black. Now, concern infrastructure providers sometimes use third-party hypervisors that do not run the OS. Yeah, and that's true. So it may not be feasible for infrastructure OS first, or it may. So I'll make that black. Are there any issues with that? Are we done with corrected errors? Okay. Non-fatal recoverable errors. Theoretically, firmware can log those. I buy that. Not feasible because I don't know why this says this. I'm just going to accept the B for because. Now, let's see. Though feasible, the BMC will need a race-free way to get the error logs without interference from the OS. That's true. I don't understand this. So you've crashed. Oh, I see. Recoverable. Oh, I take it back. I do understand this. Okay. So here's the problem. Let's do the first sentence. The problem is that if you have one set of error logging resources, like one set of registers, and the OS logs and clear them, and the BMC also tries to log and clear them, then there's a race. And the BMC usually loses that race because the BMC is, by definition, a little small processor that runs slower. And so there needs to be a race-free way to do it. The hardware can be designed such that you get that race-free condition. You can duplicate registers, or you can have a microcontroller in the hardware that actually does the logging and then provides the log to the OS and to the BMC. So there are different ways to slice that, but the fundamental requirement, I believe, is correct. So I think Anil must have written this, but I buy it.
So Drew, the firmware first and OS first are mutually exclusive, right? The one of those entities will have first crack at the error records, and then if it doesn't do anything, the next one can do it.
Yeah.
BMC based is not assumed; it's assumed to be in parallel.
Yeah.
Is that stated somewhere in here?
I don't know. I believe it is. I will take an action to look. But that is the idea. We should have such a statement. Again, fresh eyes. That's good. Good question, Dean. It's a legitimate question. We need to make that statement. I'll make sure we have it. But that is the idea. And then initial error. Okay, so I would say here that the BMC is not, this actually I don't understand again. The BMC isn't exclusively getting these error logs. So the OS has to see recoverable errors. You can't hide those if you want the OS to decide whether or not it can continue to run. You can still be firmware first, but all firmware first can do in that case is make a copy of the error log because it has to show it to the OS to let the OS decide whether or not to recover. So I need to think about that. I'm sorry, I didn't catch that. I don't know when that was added, but I missed it. This is true. Decide if it can continue running. The BMC logs in parallel and is not in the OS critical path. So I'll think about this. But if if y'all have opinions, speak up. But that doesn't make sense to me. That the recovery what I believe the main latency with the BMC is, the main important thing is there really two. Can I get the error logs out fast enough that I can, if I'm predicting crashes, I have time to analyze them? But that's a very loose thing, because let's say I can predict a crash an hour out. So I don't want to poll the BMC every 15 minutes, because that's a significant chunk of that 1 hour prediction. But as long as I get the errors out within seconds of them happening, I'm happy. It doesn't matter, maybe even a minute. But I can't build up too much latency there. And the other thing that I think that we have with the BMC is sometimes we might, and I'm not sure about this, but I think there are probably cases where we had an error, the system crashed, and we really don't want to give the system back to the customer, because like when we analyze the errors, we're going to conclude that this machine is really sick. We shouldn't, if we just put the customer that was using it back on it, we're just going to make them angry because it's just going to crash again. And so there's this kind of boot latency that, if you've crashed, ideally you'd be able to tell the machine, or tell the hyperscaler infrastructure, don't give this machine back to the customer. It's failed. Just put them somewhere else and send this machine out to repairs. So that is it. Those are the two latency things I can think of that have to be handled from the BMC side of things. And I might have missed something, but I'm pretty convinced that's it. So I will look at this a little bit and think about that. Okay, and so then the next thing that I did is I added and reset feasible, and we talked about that already, so I'm just going to accept it unless someone disagrees from our conversation last week. But the thought here is that you had something bad, you could reset, and on the reset you could gather some information. And so OS first for an infrastructure or application level work, because you can reboot, and on the reboot you can collect the error logs via a warm reset or via some microcontroller that gathered the error and put it in the BERT, or something that firmware did where it put it in the BERT for you. And so you pick it up and you say, oh, I had an error log, that's why I crashed. And you can send that up through your collector, your OS first collector. So I think that works. Any debate there? Okay. Now, I think Anil added, since the crash is not... does anyone understand that comment? I don't follow it. Let's see. Because in an application environment, let's say that, I'm providing a mapping application to some customer. When the machine crashes, I'm going to have some web front end that's going to redirect them to a healthy machine. It doesn't matter whether they can or cannot see it. They might notice it with the infrastructure too. But whether or not we get OS first error logging is irrelevant. I don't see what this has to do with whether the OS can collect the log. It doesn't really matter that it's application or infrastructure. So I'm proposed we just delete that.
What is the whole application row intended to mean?
Like Facebook would be an example. It's an application that end customers interact with. It's distinct from like an infrastructure provider, which would be like a cloud provider that rents its compute and storage infrastructure to end users. And then bare metal, there are no hypervisors, just right on the machine. So those are the three classes. But like Facebook would be an example of an application.
So this is saying you rent out just the application level.
Well, you're not renting out the application. Like in this case, Meta owns the machines, Meta owns the OS, right? That's why Neil's doing this.
Okay. They have control up through that layer.
They have control all the way up to, they even control the applications that run on the
Oh, I
machine.
see. Okay, thank you.
So they have complete control over the code running on the machine. And that's a different use case. You can do when you own all the code, you can do a lot more, as opposed to bare metal where you don't own any of the code on the machine, possibly.
Okay, so that makes sense to me, but the cell still doesn't make sense. So I'm with you.
Yeah. So I'm just going to delete it. I don't understand it. I don't think it's relevant. Okay. Now fatal system. So this is the one that used to be the oh no, this one was reset may be feasible. And really, Dean, you made a good point. We should not have embedded worm reset in this. And so I just said system firmware can execute because I'm assuming that uh, firmware is going to do something to get the logs and get it to the OS for the higher level ones. And so like, can you run code or not is the question. And sometimes if firmware can execute code, it can gather things even when the OS is kind of messed up. So we talked about this, and I say in this case, firmware can collect the logs after the fatal error. This might be implemented via warm reset, crawling out from the error condition, or getting the error logs from management process, or via some other method. So I'm just extending this a little bit to reflect what you said. There are lots of ways to do it, not just. I think we had incorrectly constrained ourselves to warm reset.
So firmware execution is really pre or post reset, right? I think the main distinction there was that system power is healthy. It's not going into continuous power loops, right? That was the only distinction, right?
It's a little bit different than that, though, Yogesh, because you can if let's just say I had the nightmare scenario where I had a die crack in a CPU while I was running, just some thermal stress happened, the thing cracked. The CPU is not running anymore, probably ever, right? It's just done. So in that case, that wouldn't be this case. The OS and firmware are never running again. Or like if I only had one DIMM in the machine.
That would be the case of system firmware can never execute, right? So system firmware can execute could be pre-reset or post-reset. I mean, right? Either system power went
No,
down.
this one is the one where it can run, but I'm just saying it's not that. Yeah. So do I need to change something here? I mean, I'm thinking I just said after the fatal error. I didn't say pre-reset or post-reset.
Can you hear me?
Yeah, we can hear you.
Go ahead.
In this case, are you saying system firmware can execute, meaning system firmware is up and running? Or what is can execute?
It just means it is able to run at some point after the fatal error. So it could be pre-reset or post-reset. It could be that you lock up and do a warm reset and gather the data, or it could be that you have a management processor that gathers it and hands it to the. And in HP's case, we back in the old PA RISC days, we actually crawled out from viral. It was super advanced. It was very hard to do. So you could be in the most fatal conditions, and firmware would gently probe its way out and rediscover the system and rediscover what was working. But that was super hard to implement. So warm reset replaced that because warm reset was easier. But now in the modern era, a lot of folks are using microcontrollers also instead of the warm reset. And that has the advantage of being able to collect things that do not persist across the reset. So that's one of the reasons why I don't want to constrain us to warm resets.
Yeah, that's fine. It's just system firmware can execute. This statement seems.
Okay, do you want me to say can execute after the fatal error and thus can collect error logs?
So Tanya, the way to think about it, I think, what the intention is, look at the opposite condition. Some error has occurred and system firmware cannot execute. So you can't collect the data. The data is stuck in the machine and you can't get it out. This is the opposite of that.
Yeah.
You have to sort of go to the next one, I think, in
That
the
was why
sequence.
System firmware is operational. to take some action, or system firmware is responsible for the action. Is
How about is able to collect the error logs after the fatal? Is that clear? I'm intentionally vague because I'm not saying pre or post reset. It could be either.
okay.
It's just able to, one way or the other. Somehow it's able to.
Okay. I wasn't in the prior discussion, so maybe since I don't have the full context, the the header fatal system firmware can execute, that threw me off. Like that sentence was.
Yeah. So should I call it can collect maybe we can collect.
Yeah, I think now I understand the context, but maybe some other header would be good.
Okay. Can you think, can you,
Yeah, I will think about it.
if you, I mean, what I'd like to do is move on to try to,
Yeah,
to correct more of or fix more of this. And then maybe next week, what we can do is if you come up with a better name, we can look at it. Or if you come up during the meeting with a better name, I'm I'm open to entertaining that. That sounds fun. But the complementary one is fatal system firmware cannot execute. So, the host is done. This is the die crack, right? Or your
this
one
is what
bad.
Dean was saying. If you look at the other one, that will make sense.
Yeah, exactly. That's why I went down there. Is what Dean said. Yeah.
Unfortunately, there's a lot of that in this document.
Well, if we can fix it,
You've been improving it.
Okay. Thank you. So, okay, so in this case, though, firmware may be able to log the error and pass the error logs to the server fleet operator. And so what I'm imagining is this is bare metal. I can't, I can't count on the OS because I may not have an OS agent. But system firmware, if it wakes up, it could say, "Oh, I just had something really bad happen. I'm going to go get this error log," and the OS is done, so I can take my time, and I can give the error log to the BMC. So, you know, uh, I think that works. So I mean, that's my intent. So hopefully that's not controversial. I'll undo that so you can see. And this was assuming warm reset, I think. And I'm just like, nope, this isn't really about warm reset. It's really about firmware can log the error after the fatal error. So hopefully that makes sense. And oh yeah, thank you, Charlie. I was going to say if someone could do that for Tanya. Okay, and then the next thing here is uh, OS first may not be feasible, and it said the OS was crashed and not able to log the error directly. And uh, I don't think that's right. I think that if the CPU is able to run code well enough to boot the OS, system firmware may be able to, help it send logs, but not with a bare metal case. So, I'm saying the same thing. Firmware may be able to pass the log. So I'm just going to delete that because it's a bare metal. Um, I don't know. I mean, we don't count on the OS. That's the key because we don't own it. So I'll accept these and then I'll take your feedback. So it's clear. Okay, so if there are no comments there, in the infrastructure case, firmware might be able to do it in firmware first. So that's the same as the previous case. And then the other stuff, the OS crashed, wasn't able to log directly. It may be possible to pick up on the BERT in the next boot for infrastructure, but maybe not. I don't know. Then in application, this is the Facebook case again. Firmware first is the same thing, and it's otherwise unchanged. But firmware may be able to log the error if you want to use firmware first, or the OS might be able to do it on the next boot with the BERT. So I didn't really change this one all that much. I just got rid of the references to worm reset and talked about what firmware could and could not do.
So whatever is resolved, let's keep taking care of all those comments also, right?
I'm sorry?
Keep accepting the comments and resolve those, right?
Yeah. That's for the next section down. They'll disappear.
Oh, okay. I see. Okay.
And in case anyone's really worried, you can look at the version history of the document. So, you know, if you're concerned, you can go back and see what the previous version was. So, you know, we're revision controlled here. Okay, so now this was previously saying, and this was what was confusing Yogesh. This is why every time I talked about this, you know, Mark Fletcher had to pull me through the knothole like 2 or 3 times when I slept after he explained it. And the thing that was puzzling about it is it was making a really special case out of, you know, where the BMC is the only thing running and the host can't run. But there's not, you know, there are lots of cases where things can't run. You might not have any working memory, or you have no I/O, so you can't boot a. Well, actually, that would still be firmware. But what if your firmware image is corrupted for some reason? You know, you have some sort of flash failure. System firmware cannot execute. You are done. Or if the die cracks, you know, in the right way, you might be done. So I don't think this is really about power. It's really about whether firmware can run or not. And so in this case, firmware that can't run, you know, the OS can't run. The only thing that can run is maybe a management processor, and they may be able to log the error. And so there may be a security issue that prevents firmware from running. It also there might be VR failures, um, you know, but nothing's working on the host CPU.
Now that's also maybe, right? It's not guaranteed that BMC will be able to run, right?
Yeah,
BMC may be able to run and log. That's the best. I mean,
yeah,
you
and
said.
then that's what it says, right? Like maybe.
Sure.
Yeah.
Yeah.
Yeah. And we've seen that before. I mean, I've seen VRs feeding a processor fail, a processor goes down and, you know, the board is dead, but the BMC is still there because it's on a low power VR rail that works even in the face of the other failure. So that's a common design practice to have housekeeping. Okay, and so this table is changed quite a bit. You know, he said since we're no longer assuming without power, so I deleted all the you know, since there is no power, because we might have power. So I'm just going to get rid of that, and that'll make it easier to see. Okay, and then we can go through the table. But so, you know, it's not feasible firmware first because the firmware doesn't work, and it's not feasible any firmware first, right? It's like if firmware can't run, firmware cannot log. It's that simple. And then the same thing with OS first is if the firmware can't run and the OS can't run, the OS can't log. You know, it's just, that's it. And then it's feasible, and you're right. I'll change that to may be able to log errors with voltage red. I don't know. Is that okay if I reword it that way, and I'll just make the others say the same thing? These three cases are really the same. Is, you know, in this situation, the BMC, you know, remember, firmware cannot execute. So the only thing that's working is, you know, the BMC or maybe management processors. So is this wording okay with you, Yogesh?
Yeah. That makes more sense. Yeah.
Okay, that was a good catch. It should have been May. Okay. Look at that. The table's getting smaller. Okay. So, and I'm going to accept this then, and hopefully that's not controversial, but if it is, I will look at it. Now, someone had added error information may be logged in warm persistent reset register will be read after reboot. No, if you can't run code, you're not going to, warm reset isn't going to help you. If you don't have power, there is no warm reset. So that made no sense. So I'm deleting that. But in the case of a full power loss, we must try to signal as we go down. That I've seen that, and it may be possible to get a message out, kind of a Hail Mary message before any parasitic capacitance or whatever decoupling capacitors lose their charge. And then otherwise you just have to go look through the data center and say, hey, machine X didn't respond. Someone go take a look at machine X, and the service person goes out and says, there are no LEDs on this machine. It's dead. And then, I think Anil wants to say that in the case of a VR fault, you might be able to get the OS to say, I can't talk to the BMC. Maybe the BMC is dead. But we're not going to cover that yet in this. So I think we're done. I think we did this section unless someone has concerns or feedback.
Good.
Okay. Hopefully this lasts. I mean, I share your frustration, Yogesh, but I think it's a little cleaner to just say, hey, I can't run any code on the host. How am I going to log it? And that's a little cleaner than VR. So I like that. Okay, and if it's okay with folks, I'll just keep going through this section then next. A heads up, I did not get around to fixing the drawing. I will. I've not given up on that, but I got sidetracked this week, so I'll work on it. I'll work on it before the next meeting. But so with that, why don't we just look at the few changes, and I think we're getting there. I mean, we're like halfway through the document, and a lot of this remaining documents, things like glossaries. So hopefully we're getting close. I agree with, let's see, figure 5. Yeah, not the figure 5. Right. Good change.
Some of the terminology that I don't know if we all are agreed. I think we still have like good 15 minutes. Do you have anything else to cover? Or otherwise, I think we should probably level set one more time on terminology. In that diagram itself,
Yeah, I was going to work my way through these proposed changes, but yeah, let's do it. So why don't you kick it off, Yogesh?
No, I was just asking a question. Are we all agreed and settled on the terminology in-band management agent and out-of-band management agent, IEMA and OMA? Because I know Anil proposed it, but I don't recall having a good discussion on does this make sense? And it's okay. I mean, probably not that critical, but just wanted to.
Well, the in-band management agent is clearly needed because, the fault management tooling for any application provider doesn't come with the OS, right? It's not built into it. They've got to build a bridge between the OS and their infrastructure. So that's just required, right? It's just not there in the OS, and so there has to be something. So that makes sense to me. The out-of-band management agent, to me, feels like someone just put it to be complete. But
Yogesh, is that Yogesh? Is that your question, or are you asking what are the terms, how they defined?
Yeah. I mean, the in-band, of course, is understood, but out-of-band agent is, it could be many different things. It's not a hardware entity that we are kind of proposing or requiring to be.
but it's not even a software. Like when we talk about the RAS API discussions we've had, we're saying that there will be a RAS API protocol that maps the RAS API to whatever protocol we want to use, whether it's Redfish or, if we're getting down here in the BMC, it could be, MCTP or APML or PECI or whatever. And so that's where I'm like, I feel like this was added to just be complete and mirror
Yeah,
website. But
that's the whole point, right? There's no separate separate. I mean, I don't know how to define that box. I mean, there is some interface point. That's the best we can say, but that doesn't. I don't know what that is as an OMA. I mean, what is that blue little box OMA, right?
Yeah. And we really don't want much there. I mean, what we want is a
Exactly.
RAS API endpoint where I can say, hey BMC, what have you got? And it goes, I've got a couple SoCs, I got 8 GPUs and a storage accelerator and a SmartNIC. And I'm like, cool, I can configure those and get error logs from them. We're set. But
I
that,
really like that. RAS API endpoint actually makes it as generic as we want it to be, right? That's really what we need there. There's a RAS API out of band, whatever endpoint in the, yeah, that
No,
yeah.
but
exactly.
Yogesh, that would be like only if it is stateful, right? If you're just
Yeah,
passing
I know,
through,
but we're not
then
getting
it's
into,
not,
yeah,
yeah.
yeah,
I think
I
OMA
understand.
is fine, right? Like you have a management
What,
agent which is out of band, and then there is a management agent in band. And
But
now,
what is that? Like none of us can that won't out of band.
okay, so let's
so
understand
okay,
that
so
box. There is a big,
if you just look at in band, right? Like whichever software is consuming the CPERS and making the decisions and like creating policies, that would be your in-band management agent,
But it's
isn't it?
not. That's actually my point, Shibata, is that the in-band management agent is a bridge between the whatever the OS sees in terms of errors and the hyperscaler's infrastructure. It's not
Mm-hmm.
it's not the brains necessarily. It's just the bridge. Because when you get an OS, you download Linux, it's not going to have something that works for. I'm going to use Meta because this is Anil's drawing, but it's not going to. OS has you download it, does not work for Meta's infrastructure. And so what you do is you put a thing in that talks to Meta's infrastructure and passes the stuff up from it as needed, right? So so this is tailored to the hyperscaler and their infrastructure. With the RAS API, there is nothing here that is tailored for the infrastructure. We have a RAS API endpoint, and we have a universal collector that is out here. Like in the if I move this up here and said, you know, I like calling it universal collector. I know it may be an overstatement, but it gets people's attention. Universal collector for the RAS API. Now I understand what this is. It's the same bridge that you have here, but it's not in the BMC.
But say you did not have that infrastructure, BMC would be the management agent for your CPU, correct?
Well, this is
You,
you wouldn't fit into this drawing. This is showing how you talk to a hyperscaler. So let's imagine I'm a Pure Storage or HP or one of those companies. Then they may choose, if you're a server vendor, to incorporate the analyzer in the BMC. And you'll need a bigger BMC, and you'll probably want a way to update those analyzers more frequently than you update your base BMC firmware, but it's doable. But in that case, that's a completely different drawing where you're saying now you could say like some server vendors in the past have had an appliance they put in the data center, and they say, hey, if you want the best warranty support from us, put this appliance in your data center. It will connect to the machines. It will look at the things that are happening on them, and it will phone home when your stuff needs repairs. But those models were always kind of hit or miss in terms of adoption because uh, people didn't always want to poke a hole in their firewall for that appliance to send a message back.
yeah.
but that
And
appliance
what
is
I
not.
see is that the management agent, right? Like BMC is a generic management out of band management agent for your CPU or GPU or whatever it is, BMC, AMC, XMC, whatever. Right? So that's what we want to show with that block, right? Like there is an in-band management agent, like whatever data you're collecting, be it telemetry, be it RAS, you have a in-band management agent within the either on the CPU and then out of band management agent in your
There's
BMC.
already there is already a green box running vendor code on the BMC, which is doing what we think OMA should be doing. So I don't know what is OMA. Still the same question.
Yeah, exactly.
Okay, okay. So you're saying there's like a overlap between what that vendor code box is, which is managing, already doing the RAS management, and then there is another box of OMA. I see, okay. So that is where
I
the
mean, you could argue, like the other thing you could argue is that like this whole box is the out-of-band management
yeah,
agent.
yeah,
But
exactly.
but 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 I know
Yeah,
some
that
BMC
would make
firmware
more
people that
sense,
scream.
including the BMC. You take BMC also in that big box, then it makes sense. Yeah, this whole thing is a OMA, but
Yeah.
some OMA sitting inside the software, I assume running on the BMC, which is sitting below. I don't know what that software is. That's my whole question.
Oh, what? Right here?
No,
No, no,
the
what I'm
green
saying
box.
is
Yeah, okay, makes
if you
sense.
encompass the BMC also in this black box, big black box where we have vendor code and kernel, and call the whole thing a OMA, then it would make a little bit more
Yeah.
sense.
Yes, that is right.
Agree, agree. Yeah, I also agree.
And the grand point of the RAS API is that I do not need a bespoke bridge between the BMC and my infrastructure because my infrastructure has a collector that speaks RAS API. So if the BMC speaks RAS API, I need to do nothing special to connect to it.
Yeah, that kind of defeats the purpose of having API
Yeah,
because you
this
still
is
need
kind of the
something.
it's kind of anti-RAS API. Yeah, I mean not intentionally, but Anil is aligned with us on what we want to do, I think. But I think this is the anti-RAS API approach, unintentionally. So that's why I would prefer to move it out and call it the RAS API collector, and and then at least we're somewhat consistent. And that makes sense. That there is a bridge. Okay, so the way I think of this is a bridge between the OS and the hyperscale's infrastructure. And what we do is we just say that bridge is a common bridge, um, but like on on the downside of this box, the interfaces are standard. That's RAS API protocol. On the upward thing to the infrastructure, that could be a gRPC at one company. It could be some database pub stub thing. I mean, who knows? It could be whatever. But see, this is a bridge between the standard stuff and the hyperscale infrastructure. There, we do need that bridge, but that bridge is not on the BMC with the RAS API.
Would that be the extensions that we're talking about?
No, well, not so. So this is a little different, and that's a great question. So what I'm saying is, this is still redfish, but so what I'm saying here is that this is proprietary. This link, like it's whatever the hyperscaler wants to use. We're not specifying. Now, it might support the RAS API or it might not. It could do things however it wants. But up to this point, we do support the RAS API. So this would be, I'll be less controversial, but RAS API collector. Okay. So now this collector speaks RAS API on this side, but it speaks whatever we want as a hyperscaler on this side.
Mhm.
It doesn't really matter as long as the error logs get to the error analysis tool and we can send CPADs back. It doesn't matter how this works. That's our problem.
Now, another thing that we need to do some reality check is the CSM next to Redfish. I think CSM is going through some existential exploration. So I don't know what it was supposed to indicate there. Is there something CSM is enhancing or doing in Redfish, or what is there in addition to Redfish itself?
What
I
is
mean, they
CSM?
were trying. This is the
Cloud
model.
service model for group.
I haven't kept up with them. Has anyone else been attending those meetings?
They did not have meetings for a very long time. They were asked whether they or not they want to continue, and they came up with some new proposal to write some white papers. So I still don't know why we have Redfish CSM.
I'd say, well, let's take it off.
Yep.
And if they come up, I'm not saying we're ignoring them, but I can't point to anything, and I can point to the RAS API. We have an active group. We're working on it. We have goals. So, let's just say it's Redfish, and like if it's a cloud service per model, great. And if Anil really wants to put it back in on the M-band path, I guess we can, but I don't know what's going on with that group. So he'll just have to convince himself that they're going to give him what he needs. No, this makes sense to me the way it's written now.
Yeah, and the vendor code and vendor modules, we are saying we're pointing FMFM and hardware fault management in the infrastructure. And then we have RAS plugins in the BMC vendor code. Do we need to clean up something there or clarify a little bit more?
Yeah,
The vendor code is
like I don't think this is necessarily vendor code here. I think the plugins are vendor code.
yeah, I mean the whole green box is vendor code. Link is API, I guess. That's how I thought I'd understand it, but yeah, is that
but like I guess what I would say is if I talk to Redfish and Redfish maps to the RAS API interfaces, then that's a protocol. Like the Redfish side of this is not vendor code, but then the plugin that actually, that the Redfish
right?
talks to is vendor.
Yeah, I think the idea was that within vendor code there are plugins from different vendors, or I think
Yeah,
there's like
I
whole
was
thing
I
is
was willing to overlook that. I don't really care that much. It's not quite. I don't think it's quite right, but I'm not worried about it because I feel like as we work our way through the RAS API, we will define it. And
because this is another one of those things. There's like an in-band plugins, RAS plugins, and there's out-of-band RAS plugins. I just want to make sure that I
I think we'll
understand.
still have plugins because if you have a PECI, let's say that you for some reason decided to do RAS API over PECI, we're going to need a plugin for that, right? And there'll be an MCT plugin, and there'll be so the plugin part doesn't bother me, and that may be vendor specific, but the generic protocol as implemented in Redfish should not be vendor specific, right? I don't really care if it's an Intel processor or an NVIDIA GPU or a Motorola, storage array. I'm making things up again, but that just doesn't matter. So that's what I'm puzzling. This is what's puzzling to me about this being vendor code.
Yeah.
But we can leave it. I don't really care too much. I did not like the OMA because I don't know what it does. But I understand there's something in here that does RAS API. Fine, and we'll work out the details and clean the box up, as we get better collateral in the RAS API meetings.
All right. Good discussion. We clarified a lot of things today. It's 5 o'clock Sunday for me.
Yeah, I think we're out of time, and I need to go talk to my boss. But I think I'm ready for a nap. This has been a good meeting, but I'm like, I think I'm ready for a nap. My head's full.
So yeah, let's stop here today. See you all next week.
Yeah, thanks everybody. This is a great group. I really look forward to chatting with you and learn a lot. And I'm sorry I talked so much today. Maybe next week. I would love it if I get feedback on this stuff. So please speak up. I appreciate those of you that help us get it right. Speak up.
Thank you for driving it too. Appreciate that. All right.
Okay. Awesome. Talk to y'all later. Have a great week.
Thanks.
A great week.
Bye.
Thank
Have a good
you.
weekend. Bye.